What's the thing that you missed the most from Earth while you were in space?
Shower. It's probably not the hardest job in the world. There's a lot of demanding jobs out there. A CEO or a minister or a surgeon or something like that. I would say those jobs are probably more demanding and more stressful than being an astronaut. Things like becoming a parent, for example, is probably a more transformative experience than.
And then Wired Greece invites you for an interview.
We have no choice but flying on other people's vehicles because in Europe we don't have.
Well, Europe isn't a waking up moment. I would go to space to spend some time away from the screen and the phone. 370 ημέρες. Και βάλε. Αυτός είναι ο χρόνος που πέρασε η Samantha Cristoforetti στο διάστημα. Πρώτη Ιταλίδα αστροναύτισσα, δεύτερη Ευρωπαία που βρέθηκε σε τροχιά, η Samantha έχει γράψει τη δική της ιστορία ανάμεσα στα αστέρια. Σήμερα προσγειώθηκε για πρώτη φορά στην Ελλάδα για το Wired Greece Autonomy Event και για να εγκαινιάσει τη νέα σειρά vidcast του Wired Greece, The Big Interview, powered by EFA Group. Samantha, thank you so much for being here with us today, landing on our studio. We're so excited to have you.
Thank you. Thanks so much.
I'm going to ask sort of a cliche question, but I always said if I had an astronaut, it's the first question I want to ask, which is, what's the view like from up there? So if you're looking from the window of the International Space Station, what does it look like?
So on the International Space Station, we are quite close to Earth. We're about 400 kilometers. So I think the first thing that people need to realize is that you're not so far away from Earth that you can see like the entire hemisphere. Mm-hmm. If you look, we have a magnificent module, which is every astronaut's favorite place, which is called the cupola. And it's the one module that has a bunch of windows.
It's the one with the circular windows, right?
It has like circular window in the middle. So basically when you float into it, you kind of have your head pointing at Earth. So you're kind of like upside down. And then it has windows trapezoidal, I guess, 6 of them around the circumference. So it's the one place that really allows you to look horizon to horizon as opposed to just looking down that you can do from some other windows, right? In other places, you have those windows that just point down and then you kind of see a piece of Earth kind of like flowing beneath you, kind of like a river. In the cupola, it's more immersive. You can look horizon to horizon. You can look kind of like beyond the horizon onto the stars and the cosmos. And so you see for, a couple of thousand kilometers on one side and on the other side. So, for example, you cannot see the entirety of Europe in one piece, right? It's going to take you a few minutes to be able to capture all of Europe with your eyes. And then, the way it looks, to be honest, is the best. The best is obviously to look at the pictures, right? I do think that, there's millions of pictures from the space station, time lapses that actually do quite justice to the view. But overall, yeah, you have this fantastic viewpoint onto the planet, and probably, at least me personally, it's especially fascinating at night.
Yeah, I bet, with the lights.
Yeah, with the lights, right? There's places of Earth that are quite dark because they're sparsely populated, which is also something that you need almost to grasp fully as a European, because we are used to a very densely populated territory with a lot of cities, and that's exactly the way that Europe looks, incredibly bright and densely populated. And then there's, vastness of Earth that are very sparsely populated, very dark at night. But it's never fully dark. Especially, if there is at least some moon up, you always get some light and you're able to make out things a little bit.
So this is the vision, and you already started talking about what my next question was going to be, which is the perspective, right? So these are the things you see, but how did they make you feel? And seeing Earth from that perspective, did it really change anything about the way you look at Earth and its problems, its challenges?
Yeah, I wouldn't maybe go as far as saying that there's something about going to space that fundamentally changes your life or gives you some kind of insight or enlightenment that, otherwise is not accessible to people on Earth. Sometimes they call it, I think, the overview effect, and this is what they sometimes understand with that word. I mean, I wouldn't go that far. I don't think I have had that experience, and I also have not observed it in other people. Things like becoming a parent, for example, is probably a more transformative experience than the fact of looking at the Earth from space. That said, it is a peculiar perspective, and you basically fly around the planet in 90 minutes, so about 16 times per normal Earth day, let's say. So you do have this feeling that you're really like embracing the entire planet every time you fly around it. There's places that I've never been to that are incredibly remote, very far away. I would probably maybe never go to. But somehow from the space station you feel very close, because again, you're only at 400 kilometers, and every single piece of the Earth's surface between 51 degrees latitude north and south, you overfly it.
And my last question is, we've kind of heard about my last question about your personal experience. We've heard about the demands of being an astronaut, right? It's really exhausting, takes a lot of prep. Give me your take on it. How exhausting was it to prepare to go to space? And then after spending, I think the max you spent was 200 days consecutively, right? How exhausting is that experience? Like coming back, were you physically drained, etc.? So what are the demands of the life of an astronaut?
I would probably caution by saying that it's probably not the hardest job in the world, and there's a lot of demanding jobs out there. I was in the military before joining the astronaut corps. Imagine you're deployed in an actual operational theater. With active military operations ongoing, and imagine how stressful that might be, and how demanding and difficult. Or imagine just, having jobs with incredible amounts of responsibilities, like, I don't know, a CEO or a minister or, a surgeon or something like that. I would say those jobs are probably more demanding and more stressful than being an astronaut. So I think it's always good to put things in perspective. And also, I think that, especially on the space station, as long as you're feeling well physically, I mean, some people have a little bit of a difficult time adjusting to the weightlessness, but I was lucky that I felt just fantastic in space. And, as long as physically you're doing well and you have a good relationship with your crew, and, things are actually really nice. I mean, I really enjoyed being on ISS. Both of my missions I found coming back more stressful. Both the physical adaptation of coming back to Earth, I think, is more stressful, for me at least, than adapting to weightlessness. And also the demands that are put on the astronauts after you're back. There's a lot of demands put on your schedule. There's a lot of science that still needs to be done. There's a lot of public outreach activities that have to happen.
And then Wired Greece invites you for an interview.
Well, this is just I'm fantastic here today, but I'm really talking about that time after the mission, when actually you would like to be able to relax and take time with your family, and you're not really quite allowed to do that. That I found the most stressful time, but up in space, I just found it fantastic.
Wonderful. Let me ask you a little bit about the state of affairs now when it comes to space. We have had renewed interest. We have had commercial interest in space as well. So, we're kind of entering this new space era. What's your take on it? Do you think it's this sort of new golden age of space exploration? Are we also looking at geopolitical competition here? So what's your take on this sort of new space race and the way things are moving?
Yeah, it's interesting you use that term space race. And first of all, one really needs to understand, or at least we need to agree, what we mean by that, right? A lot of people, when they think of space race, they think back at the Soviet Union versus the United States during the Cold War. That would be more like a race between sovereign actors, more geopolitical, let's say. And that is certainly an element of what is happening. And in this case, it would be more between the United States and China. China has done incredibly fast and substantial progress in their space capabilities. In low Earth orbit, which is where the International Space Station is, they've basically demonstrated all the same capabilities as the United States or Russia. They have a very successful lunar program, even a Martian exploration program, and they have a very clear stated goal of being able to land humans on the moon by the end of this decade. And they're usually very diligent and thorough in following through with their plans. The United States is the leader of the Artemis program, of which in Europe we're also part, which is also a program of moon exploration. So in their case, it would be a return to the moon after the Apollo program of the 1960s and 70s. And I would say that there is definitely a lot of pressure felt in the United States about getting back to the moon before the Chinese make it there. So there's an element. Behind it, of course, there is also the fact that, also from a military security point of view, the space-based assets are recognized more and more as fundamental elements of basically warfighting capability. And so there is obviously also competition there about making sure that you stay at the cutting edge of capabilities and you're able also to protect those assets against potential hostile activities. So there's that one element, but then nowadays, and this is more of a modern take or contemporary take, if you talk about space race, you could also see it under or from an economic lens and more talking about competition between economic actors.
Right.
I think what captures a lot the imagination of people is when those actors are associated with individuals that somehow have become
personas.
well-known. Personas, almost symbolic, right? Everybody knows Elon Musk, of course. Everybody knows Jeff Bezos. And they happen to be behind, for example, the two companies that have the contracts of NASA to develop what they call the human landing systems, basically the vehicles that are going to bring humans, crews, from the orbit of the moon to the surface of the moon. So two of them are in development, one by Blue Origin, Jeff Bezos, and one by SpaceX, Elon Musk. So one could see there a space race. Again, there's a lot more behind it than who builds the human landing system first. There is a lot of economic value especially in deploying mega constellations in space.
Well, on this commercial front, something I noticed is, you had this trip around space. It got a lot of attention because it had celebrities on it, right? You had the Katy Perry being one of the passengers. And I think because of that, there was almost sort of a negative reaction in part of the population that said, what is it now? Is space sort of a playground for the wealthy to go on to their journeys? And what do you make of that sort of discourse? Obviously there's commercial interest about these NASA missions, but there's also this new sort of idea of exploring space, something that's sort of a luxury. How do you think that is sort of affecting people's perception about what space really is like?
Yeah, it can be confusing, right? I mean, and the media, some generalist media, of course, I'm sure Wired is very diligent.
An exception.
But the generalist media, sometimes they mix things up a little bit because I think the flight that you were referring to is what we call a suborbital flight. Right. So you're actually not getting to orbit. This is maybe a fun thing to say, right? But, when we think about a rocket launch, we think about the rocket going up. But the rocket is really only going up for the first few minutes, and then it kind of pitches over. And for the rest of that launch ascent, it's almost going horizontally. Because, if you just go up and then you shut down your engine, what you're going to do is fall back down. Or you're gonna get, you have a little bit of inertia, so you will keep going up and then eventually you come down. And this is what these suborbital flights are, right? You're basically going up and then you shut down the engine, you've got a little bit of inertia where you keep going up and then you come back down, and for a few minutes you're weightless. And of course you're high enough, above the 80 kilometers or 100 kilometers. I'm not sure where they do the cutoff for calling it space, but you're high enough that you see the blackness of space and you see the curvature of the Earth, and again you feel weightless for a few minutes, and I'm sure that is a fun and interesting experience. But you're missing that part that actually gives you enough speed, horizontal speed, that when you shut down the engines, you don't fall back down, you stay on orbit, right? So do we want to conflate and call it all the same, like a suborbital flight that just goes up and then falls back down, or actually going to space? Probably we shouldn't do that, but because it creates a little bit of confusion. Yeah.
Right. Let me talk to you about Europe now, because you mentioned before there is and has always been this geopolitical race, so to speak, in different terms than the Cold War, right? But the big players, what are they? You mentioned them before, United States on the one hand, China on the other hand. Where does Europe fit in? So obviously we're partnering with the US on a lot of these programs, right? But can it sort of remain a major space power? And what's your take on it? I know the European Space Agency has been doing a lot of exciting work. It's also stepping up. So how do you see this evolution?
Yeah, so Europe is in a position of having to catch up, I think, on a number of things. Certainly there are areas of excellence in Europe. If we look at our Earth observation program,
right.
like
Copernicus is fantastic.
Fantastic, certainly world class. We have our own navigation system, Galileo, which is on par with the GPS. So those are certainly areas of success. I mean, Europe has done amazing science missions, just to explore the solar system and the universe. So those are all good things. But then there are areas where we are definitely, we can maybe call ourselves junior partners if we talk about, for example, exploration, right? I always like to tell people, I had the privilege of being in total over a year on the International Space Station over the course of 2 missions. The first one was in 2014. I flew to ISS, to space station, on a Russian rocket, the Soyuz. And then, fast forward to 2022, I flew again to ISS, and this time on an American rocket and vehicle, so the Falcon 9 and the Crew Dragon. And those were amazing experience, and exploration is and should remain very much an international endeavor. But it's not like I was on an exchange program, right? We have no choice but flying on other people's vehicles, because in Europe we never had, and we are also currently not developing our own crew transportation capability. Now one could say, who cares? We can just fly on others, other countries' vehicles. That's fine. That is a potential choice. But then we really confine ourselves to the status of a small, very junior partner.
Right.
And again, if I stay with the example of, what we call exploration, which is, when astronauts fly and go places, we saw it very clearly recently at the end of March. There was an event which was called Ignition, in which NASA announced a change of plans for the Artemis program, for the lunar exploration program. And, of course, it's in their right. They're definitely the leaders of the program. And, both financially and technologically, they are by far the leader and the most important partner. So it's in their right to change the plan, for sure. But we were certainly not consulted. And one of the things that happened, for example, is that they canceled or paused. I think the official word is pausing the Gateway, which is a space station that was supposed to fly in moon orbit, which was one of our main contributions to the Artemis architecture from the ESA side. We have another important contribution that remains fundamental, which is the European Service Module, so a component of the spaceship Orion that flies astronauts to lunar orbit. But then the other big contribution was a big chunk, let's say, of this space station Gateway. Now, I'm not going to get into was the decision right or wrong. One may argue that it was the right decision or not. It doesn't matter. But the point I'm trying to make is that we didn't really have any say in that decision.
Right.
Although we have had for many years significant industrial investments in this development. So this is the type of situation in which I think we don't want to find ourselves in the future. And
right.
It's not something that you can change overnight. It's not even only about increasing the budgets, although that is very much an important part of it. Right? But you have to put in the work, the development work. You have to do the technological developments. You have to work with industry. You have to create the products and the capabilities, and it takes time.
Yeah. Well, Europe is in a waking up moment in general about its sort of autonomy, and a lot of infrastructural questions, technology included. I think space included too. So hopefully, it's the kind of wake up call that will get us there. I want to ask you a different question about how do you envision the job of the astronaut in the future, right? So we're living in the age of AI and robotics and automation. So I feel like every single occupation is kind of worrying or trying to project what will this look like in a couple of years. So you're seeing the trends. How do you think the astronaut of the future looks like? And what are the kinds of things that AI, automation, robotics can sort of come and complementarily sort of help a mission, and will there always be sort of a need for the human element in space exploration?
Yeah, that's a very good question, right? And as you rightly say, this is a question that a lot of people are asking themselves in many professions. I think that the intelligence, the knowledge, a lot of it can more and more probably be outsourced to AI, like in many other professions. And certainly there is an element of, there is an enabling element, I would say almost, because if we're talking about a mission to Mars, for example, not in the near future, but, hopefully one day, then we're talking about being very far away from Earth. It can take up to 20 minutes to even communicate back and forth.
Right.
So, on ISS, we have the privilege of having all the experts that we need if we have a question or a medical situation, for example, available on radio and comm, on space to ground, because there is almost no delay. So you can talk to them real time, but that's not the case if you're going to Mars. So the classic, obviously, use of AI is like, okay, then you can have all of that intelligence with you, with an intelligent system. And there is an element, of course, of the physical presence, that there's a lot of activities and tasks that astronauts have to fulfill that, actually require hands and eyes and your physical body and physical presence. Can that be replaced by robots, by humanoid robots one day?
Who knows?
It's possible. Who knows? It's probably going to happen on Earth first, I would say. Just because in space you have an element of, you're far away from the factory, you're far away from maintenance, you are very constrained. Most of it, depends how things will go, but at least today you're quite constrained energetically. The human body has a lot of issues, but it's quite efficient from an energy consumption point of view. It's difficult to beat the human body. So again, it might happen eventually. I would say we'll probably see it happen on Earth before we see it happen in space.
One last question about space, which I think Europe has done a lot of great work on, and some of our readers were interested in, is the idea of debris, right? So the more we have our activity in space, the more we explore, the more we put things out there. Well, there is sort of this consequence of debris accumulating, which can endanger missions themselves, right? Because you need to track it. But then also there's the question of, is this sustainable? Should we develop sort of removal operations? And I know Europe is doing a lot of good work there. So tell us a little bit about how big of a problem is it, and what are the sort of solutions that we can put on the table? And how is Europe contributing to the issue?
Yeah. So first of all, full disclosure, I'm not an expert on the topic. So, I have a generic grasp of the problem, in the sense that I fully understand that the community is concerned about it, that there's a lot of discussions and attempts to mitigate the issue. And as is often the case, there's the two paths, and they both need to pursue it at the same time. There is the regulatory path, where you say, hey, when you develop a satellite or a constellation of satellites or a vehicle, you really got to think about the end of life. You cannot just think that at the end of life of your satellite, you just leave it there for decades. That's just not okay. And we actually don't have a strict regulation about that yet. And it's also something that would have to happen on a global scale, right? And so that makes it also a little bit.
You have the same problems you have with any kind of global regulation, right?
Yeah. I mean, it's kind of like space traffic management, if you want, right? I mean, we I think it was after World War II that we instituted ICAO and the planet-wide, let's say, airspace regulations that allow us to have a very integrated air travel around the globe. But I think back then maybe it was a little bit easier because you already had regulations at the national levels or regional levels, and you just kind of had to harmonize them, like recognize that you needed something global and you harmonize it. Plus, it was after World War II, there was a big drive to, multilateral agreements to settle the way we live together on this planet. Now we just live a little bit in a different age, and it's not like nationally or regionally we have space traffic management regulations that we can harmonize. So that makes it a little bit more difficult, but hopefully we'll get there. And then, as you mentioned, the other path is technological. Again, are there ways that we can, also in a cost-effective way, because that is also part of the equation, make sure that a satellite, does not become a debris risk at the end of its lifetime. Those that are already up there, or if something goes wrong, can we have a debris removal technology where we kind of like actively go and, take them down so that they do not pose a threat?
Wonderful. Now I'm going to ask you a double punch question to conclude the vidcast. First question is, what's the thing that you missed the most from Earth while you were in space?
Shower.
I should have thought of that. And what's the thing, the second question, what's the thing you thought you would miss, but you didn't end up missing from the Earth?
My phone.
Ah, great. Honestly, I would go to space to spend some time away from the screen and the phone. Samantha, thank you so much for being our first guest here at the big interview. It was a huge pleasure to have you here.
Thank you, Nico, and thanks to everyone listening.